I'm again continuing with a series of addition of different groups to carbon double bond. So today I've selected the topic that is orientation of addition. So now I just proceeded. The most commonest or the most easiest mechanism presenting addition reactions of which group? Of course, of hydrogen bromide, HBr, hydrogen bromide and 2-butene is of course applicable to number of or numerous electrophilic additions. Now, if we add hydrogen bromide to 2-butene, it can result in two products. If you add a hydrogen bromide, right, to what? To 2-butene, you are going to get two products. That is, tell you, CH3 to C double bond CH3 plus HBr. What you are going to get? You're going to get, of course, CH3 C, then of course the CH3 will be here, then the bromine would be here, and then of course you'll get a C again. It has got a hydrogen over here and a hydrogen over here, and again a C that would be having a hydrogen there, a hydrogen here, and a hydrogen here. CH3, C, CH3, Br, CH2, CH3. This is the product which would be, you can call it an observed product. The other one is not an observable. Now here in this reaction, the double bond is protonated. Now I will show you how that goes on. You will see in my next figure. Now here in this reaction, the double bond is simply protonated. First step, we could get a different product if proton is added to a secondary carbon. Keep that thing in your mind, secondary carbon. As shown here in the figure below, now I'm going to tell you how it happens. I'm going to make it for you. Now here you can see the proton is added to the secondary carbon. I've given the direction also, a note also, so that you can proceed. Now you can further see what is happening. You will see CH3, then C. You will see the formation of a carbocation. Something is happening here. As I just said, that proton has been added. So this is a carbocation. And of course, the rest of the group, CH3, with the release of the leaving group, that is the bromide. Okay, as a leaving group it leaves, and you get a tertiary carbocation. I'll write it with a different color. A tertiary carbocation. This is a tertiary carbocation, formation of a tertiary carbocation. You can see here easily. And then if we proceed further, Now, if there is a hydrogen bromide here, now what is happening here, you can simply see. There it is. Will result in forming a secondary carbocation. A secondary carbocation. Here you can call it a secondary sec carbocation. I hope you are getting the reaction, how it goes on. I'll tell you what's happening. See the formation of a secondary carbocation. Initially now in these reactions, which I've just mentioned here, in these reactions we can simply observe that on adding proton to a secondary carbon, a tertiary carbocation is formed, and on adding proton to a tertiary carbon, a secondary carbocation is formed. And we know that tertiary carbocation is stable, resulting in forming the first reaction, the one reaction which we have done earlier. So we can get the final product of addition reaction between hydrogen bromide and 2-methyl 2-butene from second half of the reaction mechanism. We can, that is CH3, CH3, CH3. So now what's happening here? If a bromide ion is here, right, it's going to attack what? Definitely this is a carbocation. So it's now going to attack the carbocation, right? Resulting formation of what I just mentioned. Br, CH, and yes, CH3. Now here it's to be pointed out that on protonating one carbon of the double bond results a carbocation. On carbon that was never protonated, as proton gets itself attached to that end of the double bond that has, you can say, or that was less substituted, get itself attached to the one that is less substituted, that has got less substitutions, substituted, resulting into a more substituting. What it would be going to get results in getting more substituted carbocations. So I can again explain these lines again, that initially now if these reactions we can observe that on adding a proton to a secondary carbon, a tertiary carbocation was formed, and when we add the proton to the tertiary carbon, a secondary carbocation was formed. So interesting, what an interesting concept. And we know that tertiary carbocation is more stable. It is more stable, resulting in forming what? The reaction which I showed you in the initial stages. That was the first reaction, and we can get the final product of addition reaction between what? A hydrogen bromide, that was HBr, hydrogen bromide, and of course 2-methyl 2-butene, 2-methyl 2-butene. to butene, and from second half of the and you can get the this type of results from second half of the reaction mechanism. Now here simply it's to be pointed out that on protonating, one carbon of the double bond, one carbon of the double bond results in a carbocation, and on carbon that was never protonated. As you know, proton, it gets itself attached to that end of the double bond that was less substituted. Proton has the nature to get itself attached, bonded to that end of the double bond. Double bond has both the ends, so it gets itself attached to that end of the that double bond that was less substituted, that has less substitutions, resulting into forming more stable substituted carbocations. That is here, more stable substituted carbocations, as it gets itself attached to that part of the, or that end of the double bond that was less substituted, so it could be able to get more substituted carbocations. So this was something very interesting and very short. I explained you just to make you focused on orientation of addition to carbon-carbon double bonds. And I found it very interesting, and I found this as the most easiest mechanism that could explain us the addition reaction of hydrogen bromide to 2-butene, and was definitely applicable to numerous electrophilic more addition reactions. So I explained you in the beginning how you add to HBr, that is hydrogen bromide, to 2-butene, and you get the two results right in the first two reactions. You can see the first reaction, and in that reaction the double bond was protonated. That was the first step, and we could get a different product if proton is added to a secondary carbon, as I've shown in my next second reaction in which proton was added to the secondary carbon, and what you got a tertiary carbocation. A tertiary carbocation was there, and then of course a second and we simply got the idea that on adding proton to a secondary carbon, a tertiary carbocation is formed, and on adding proton to the tertiary carbon, a secondary carbocation is formed. And as tertiary carbocation is very stable, resulting in forming the first reactions, right, which I showed you initially. The first reaction, that is reaction number 1, and we can get the final products by simply reacting of reactions between a hydrogen bromide and 2-methyl-2-butene from the second half of the reaction mechanism, which was this was the second half of the reaction mechanism, in which you must see, or it's pointed out, that protonating one carbon of the double bond results a carbocation. And on that carbon that was never protonated, as carbon gets itself attached to that end of the double bond that was less substituted. And what it got in the end, because its its aim is to get the more substituted carbocations that are more substituted. So this was it. I hope you like this video. You will compare it with your notes provided to you. Please go through them, compare it with your notes, and you will get some knowledge from these reactions, how this is all going on. Hope to see you again with something new, something more interesting and exciting. Thank you so much. I'm Professor Dr. Mchem from Dr. Mchem's Institute of Chemistry, University of St. John, Sharo, and I hope you like this video, and you will definitely learn and you will memorize. Thank you very much.